Welcome back to Python Scripting for GIS Applications. This is spring semester, and this is a class at the University of Alaska Fairbanks. This week I'm going to teach you how to do basic geoprocessing in Python. And you'll have a choice of 2 out of 4 problems to solve as your weekly assignment. And the first problem is a classic distance problem. So here we've got locations of radio-collared animals, and there's 30 locations. And we've also have willow polygons. And your script would select out from these vegetation polygons all the willow polygons. So basically your script would select out the willow polygons. And then the question is, for each animal location point, what's the distance to the closest willow polygon? And then of these 30 animal location points, what's the mean distance to the nearest willow polygon? So for example, our first animal location is down here, and the distance to the closest willow polygon from our first animal location point might be something like 63 meters. So basically your script would loop through all 30 points, and for each of the 30 points determine the closest willow and the distance to the closest willow, and then calculate the mean distance to the closest willow for these 30 location points. Okay, so the first problem was a classic nearest distance type problem. The second problem that you'll have an option of solving is a classic adjacency problem. So here we have the Chena River downstream from the Mitchell Expressway to the Tanana River. And then we have all the parcels that are taxed. And what we want to do is write a script to select all those parcel polygons that are adjacent to the Chena River. So in other words, they have, as part of their parcel polygon, frontage on the Chena River. And then the question is, of all those parcel polygons that are on the Chena River, what's the mean land value? So basically what you would do is, for each polygon, is determine if it's on the Chena River. So for example, this polygon has a distance of 0 to the Chena River, and this polygon has a distance greater than 0 to the Chena River. And then basically select all the polygons that are adjacent to the Chena River, and then what's the mean appraised value of the land value of all these parcels that have frontage on the Chena River. Okay, the third problem is a classic clipping application. And the example here is, here are some wildfire polygons in interior Alaska. And then here is the refuge boundary for the Canute National Wildlife Refuge. And your script should cut out all the wildfire polygons that are inside the refuge boundary, and then compute the area of those wildfire polygons in hectares. And then the script will save to a shapefile a new polygon shapefile named refuge fires. So basically you execute your script that uses this refuge boundary as a cookie cutter, and it cuts out all the polygons inside that refuge boundary, and then for each cut polygon, calculate the area in hectares. So you run your script and you get your refuge fires that are inside the refuge boundary. Okay, and the fourth problem is a classic containment problem. So here we have ecoregion polygons within the boreal area of Alaska. So for example, this polygon represents the Yukon-Old Crow Basin ecoregion. And here are all the lightning strikes from last June. And the question is, within each ecoregion polygon, how many June lightning strikes were there? And then what was the density of lightning strikes per 100 square kilometers within each of these polygons? So that's the fourth problem that you'll be solving optionally for your homework assignment that's posted on the website. Okay, so let's get started, and in the next video session I will teach you how to do buffering using Python scripting.